All right, guys, so let's continue on with our verifying. And we've got here the cosine of theta, cotangent theta, all over 1 minus sine theta, minus 1 equals cosecant. So we're going to start with the more complicated side. So we're going to go over here and try and get this to all equal out to cosecant. So what that means is I'm going to come in here, and I'm going to simplify these two first in my numerator. So I'm going to put those both into terms of sine and cosine because cosine and cotangent just feels really, really weird right now. So what I'm going to do is I'm going to take that numerator, and I know I have cosine theta, and cotangent we can rewrite as cosine theta over sine theta. We still have our same denominator. It's that 1 minus sine of theta. And we still have this minus 1 over here, but we know already, I'm going to need to actually have our common denominator here. So I'm going to go ahead and switch that to be minus 1 minus sine theta over 1 minus sine theta. So it's still 1. It's just a weird looking 1. And we're up to that equal sign. So we can see in this numerator here, what I really have is cosine times cosine theta. So I can rewrite this as cosine squared theta over sine theta minus all of this piece. So we're going to have minus 1. Whoops, my screen went weird. There we go. And then we're subtracting this sine theta as well. So then we have plus sine of theta. Oh my gosh, stay in full screen. My screen's being a grumpy guess. There we go. And it's all still over that same denominator, 1 minus sine theta. So now I have even more pieces in the numerator, and I need to get all of them up to a common denominator. So I need to make all these pieces have a sine theta as a denominator. So my numerator is going to turn into cosine squared theta over sine minus sine theta over sine plus sine squared theta over sine theta. So we're getting those all to be that common denominator. So now we're going to have our numerator of this fraction. Now it's just over sine of theta. And we're going to have cosine squared theta minus sine theta plus sine squared theta. So I've got my numerator of the numerator to have a common denominator. So now I'm going to take the fact that this is one gigantic fraction, and I'm going to switch some things around because I really hate drawing this gigantic fraction. So I'm going to take, switch colors again, my numerator, which is my cosine squared theta. I'm going to scooch some things around because I'm going to put my sine squared theta nearby, minus sine theta over sine. And we're going to put this times the reciprocal of the denominator. 1 over 1 minus sine theta. So now we're going to look in here and we're going to notice this guy looks awfully familiar because that is one of our Pythagorean identities. So cosine squared plus sine squared is actually 1. So this is going to turn into 1 minus sine theta over sine theta. My numerator times 1 is just what this is. So then we have sine theta times my denominator, 1 minus sine theta. And we can see here the 1 minus sines cancel out. So we're left with 1 over sine theta. Well, 1 over sine theta is the same thing as cosecant. And what we have is way back at the beginning, all the way up at the top, that was our whole goal. Our whole goal was to get this to equal cosecant theta, and we just did. So we have now here our cosecant theta equals cosecant theta. And we have proved that the left side equals the right side. So I'm getting the whole thing out for you guys. There we go. So there's the whole thing. So we started by trying to get all of our sines and cosines together. Then we got some common denominators. Then we had to do some multiplying by a reciprocal, some canceling out, and we got all the way down here. So let's do another one. So we have another fraction looking one. So what we're going to need to do here, everything's already in cosines and sines on the left-hand side. So I don't have to worry about switching things over. So what we're going to do now is we're going to get to some common denominators. So on my left-hand side, I want to get to a common denominator of cosine theta times 1 plus sine theta. That's going to be our common denominator. So what we're going to have as our numerator, this left-hand side is going to be multiplied by 1 plus sine theta. So we're going to wind up with 1 plus sine theta squared plus, and same thing happens on the other side. We wind up with cosine squared theta. So then what we're going to do is we're going to need to multiply this out. And you can either do this with a substitution. You could do like a U substitution. You could put this in a box. You could just draw it out and distribute. Either way, when we do our 1 plus sine theta squared, we should wind up with 1 plus 2 sine of theta plus sine squared theta. That's just the 1 plus sine theta squared. And then we still have that cosine squared theta. And our denominator hasn't changed. And now we're going to see over here again, this is our trig identity again. One of our Pythagorean identities, sine squared plus cosine squared equals 1. So what we now have as our numerator, we have 1 plus 2 sine theta plus 1. And everything else stays the same. So then I'm going to combine some like terms in my numerator, and we get 2 plus 2 sine theta and I'm going to look really closely at that numerator, and I'm going to notice that I actually have a common factor I can pull out. This has a GCF. I can rewrite this as 2 times 1 plus sine of theta. And if we look closely, we can see why I might want to do that. Oh, y'all, I've gotten this theta here a couple of times. A few lines up. There we go. Oh, got it on that one too. I got it on that next blue one up. There we go. Don't drop a theta. So we have our 1 plus sine theta still down here on the bottom. And the reason I wanted to factor out that too is because my 1 plus sine theta is actually cancel out, and we're left with 2 over cosine theta. Or you can write it as 2 times 1 over cosine, which is the same thing as 2 times secant theta. And if we look way back up at the top, that is exactly what we were trying to get this to equal. Okay, so those two are a little bit more complicated with our fraction things. So give a couple more of those a try. Go check out the homework and see if you can do one like this.